All right, let's not be talking about the quiz since the camera has started. Now, since that quiz took too long, I think we should do the lecture first, so you can actually do the homework. No, you have to do the last one. We split it up into two parts. Okay, so today we are learning how to compute the area of a polar curve.
That was a different one. That wasn't the button.
So let's start with the circle.
Oh.
Let's say you know the radius of a circle and the central angle here.
I'm sorry, is this a lesson?
Yes, this is the lesson. How do you compute the area of that sector? And we learned this in trigonometry, data calculus.
1/2 beta r squared.
Yeah, there you go. The area, this is kappa now, it's not a K, that's the Greek letter kappa. The area of a sector is 1/2 r squared theta. Does that sound familiar from last year? Or do we need to derive it? I think we should derive it. What's the area of a whole circle of radius r?
Pi r squared.
Pi r squared. And would you agree that this sector is just some fraction of the circle?
Yes.
And what fraction is it? Like when you did this in geometry, you went theta over 360, right? Because there's 360 degrees in the circle. But that's in the old days when you used to do degrees. Now we do radians, so it's theta over 2 pi. And whoa, the pi's cancel out, and what do you get? 1/2 r squared theta. This is how you derive it. However, what are you playing a prank on her or something?
No, I need the textbook.
But what would happen if the angle is infinitesimally small?
D theta.
It'll be d theta then.
The theta.
D theta. So what would be the area of that really thin sector right there?
1/2 r squared d
1/2
theta.
r squared d theta.
I'm on it today.
That's right. So this is how we're gonna integrate this over whatever the theta 1 to theta 2. You know what? Why don't we put that in there? Then we're gonna integrate it from theta 1 to theta 2, and that's how you compute the area of a polar curve. So let's take a look at some examples. Let's start off easy. What if you have r equal 4 cosine theta? Compute the area of this graph. Now, before we even start, you guys should actually know the answer, right? Yeah, it is, because what is this graph? Wait, let me just call on somebody at random. Park?
Circle.
It's a circle. And what's the fastest way to graph a circle?
Draw it.
Well, what did we teach you last year? You plug, not just the quadrantals, you just need to plug in 0 and pi over 2, and that's good enough already. If you plug in 0, you get? Come on. 4. You plug in pi over 2, you get 0. This is the diameter of the circle right there. So it goes like this. And remember, if you graph it from 0 to 2 pi, it actually goes around twice.
Nice.
You know why? Because look, theta is 0 here. Theta is 0 there. Then pi over 2, and pi, 3 pi over 2, 2 pi. So it actually goes. So you can actually make the whole circle just from 0 to pi. And again, it's not enough to know how the graph looks. You got to know how it's formed so you can figure out your limits of integration. So here we go. How do I find the area of this? And of course, it's a circle. So what should the answer be? Pi r squared.
No. Wait.
What do you mean no?
Yeah.
Pi r squared. Look, the radius is 2, so pi r squared should be. We know the answer should be 4 pi, but let's see if we actually get that. So 1/2 r squared d theta. But what is r equal to in this problem?
4 cosine theta.
4 cosine theta. And what should my limits of integration be? 0 to 2 pi?
0 to pi?
No, 0 to pi. Or, if you're clever, how about just go 0 to pi over 2 and times it by 2?
Oh, get rid of
right? Because zero, see what's happening is from zero, you're taking up all of these sectors infinitesimally thin like this. And you're adding up all of these infinitesimally small sectors to get the area. That's what we're doing when we do a polar integral. Okay, now the next thing is, of course, how do we compute this integral? Well, this 2 cancels the 1/2, and what happens when you square this? You get a 16. And what's the only way in the whole world to integrate cosine squared?
Identity.
1/2.
1/2 plus 1/2 cosine 2 theta. Or you could have just gone 1 plus cosine 2 theta over 2 and bring the 2 out here. But whatever. 16. So the antiderivative is 1/2 theta plus 1/4 sine 2 theta. I'm still fighting with my AB students because they still cannot. They make me want to jump out the window. Plug in the top number. Go. Plug in the top number.
1/4, pi over 4.
Pi over 4 plus. You know, I can do this in my sleep. Can you guys do it when you're awake?
No.
So you get 4 pi, which is what you're supposed to get. Okay, that was an easy one. Are we ready to kick it up a notch?
Yes.
So again, see, you have to know how the graph is formed so you can get your limits of integration. Because anybody can go 1/2 r squared to theta, but you got to know your limits of integration. Not much time. I want to do.
Wait.
Oh, you're erasing already?
Well, we have to stay on this side of the board because we're videoing.
Or
You-
Anya.
Woo.
It's on the video.
Yeah, it's on the video.
But I don't want to
Screenshot the video.
I don't want to go back to the
Can you
video.
screenshot a video?
Yeah.
No.
Yes,
Yes,
you
you
can.
can.
Wait, what did you erase
I
then?
don't know. I never
You
tried
did go
that
back to the
before.
video.
Okay, now I forgot the example we're supposed to do. You want shout? We only might have time for one. So you want to do an inner loop or one petal of a rose curve? I wanted to do both.
Rose.
Let's do the inner loop first. R equal 2 plus, let's keep it simple, 1 plus minus 2 sine theta. I'm trying to make it easy for you.
Thank you.
Okay, no, yeah, this is not the rose curve. This is a limousin with an inner loop. How do I know?
Because you're the teacher.
No, because this number is smaller than that one. If this number equals that one, you get a cardioid, right? If this number is bigger than that one, then you get a blob, right? Or the Manapua.
Oh yeah.
We went over this is review.
Oh jeez.
No way.
Where do you go?
In August,
Just remember it.
August, Davis, August.
I just said we just have to remember it.
Plug in the quadrantal angle, 0. Pi over 2, negative 1. Ooh, that's a hint right there. Pi, 1. And then finally 3 pi over 2, 3. So you gotta go 3 units in the direction of 3 pi over 2. Do not think rectangularly. So the particle starts here. Well, it's not a particle. The graph starts here. It goes like this. Oh, that's pretty good. A little emaciated there. There you go. So notice how the graph is being formed. It starts here. It goes like this. So right about there, that's when the inner loop starts. Boom! Right there, the inner loop finishes, and then it goes along its merry way. Like that.
It always intersects.
Yes. How do we know the inner loop always passes through the origin right there? Or the pole, they like to call that, the polar coordinates. We gave you the answer last year. Davis, you said you remembered. Why does the inner loop have to pass through the origin?
There's time.
Okay, follow?
Because when it gets to 0, then it's just going to be 0 radius, which is going to be the origin.
Yeah, but yeah, so how do you know it has to pass through there?
Because of that. Oh.
Love?
Because when theta is pi over 6, then the r is equal to 0.
Okay, but I was hoping for, somebody was gonna say the intermediate value theorem.
Oh, yeah. That's not
Because what is the r value right here? rhymes with bun.
One.
What is the R value there?
One.
No, -1. So to get from 1 to -1, don't you have to hit 0 somewhere in between? That's called, okay, if it's 1 here and -1 there, don't you have to hit 0 somewhere in between? That's the intermediate value there. So that means over here, you're 1 unit from the origin. Over there, you're -1, right? 1 unit in the opposite direction. So somewhere in between there, you have to hit 0.
And then it goes.
Okay, so here we go. 1/2 r squared d theta. What is r squared? Well, that's r, so 1 minus 2 sine theta. And I'm gonna add up all of these sectors from, now, when does the inner loop start and when does it finish? When? Right there. How do you figure that out? Okay, Lum said it. When r is, right,
R
so
is
0. No, when r is, no, right when it starts. How far are you from the origin? 0. So you put, r represents how far you are from the origin. So to figure out where it starts and finishes, you just set r equal to 0. So 0 equals 1 minus 2 sin theta.
What? Whoa.
2 sin theta is equal to 1. I saw Mrs. Sin today. Sin theta is equal to 1/2. Except she's not called Mrs. Sin anymore.
What?
The
Who's
physics teacher.
We have a.
Is she, isn't that the librarian?
Who?
Is it Mrs.
No,
Chen?
that's another sin. But
Miss Sin is the librarian.
But when I taught her, and she was on the math team too, the physics teacher,
Chen?
Chen!
Oh.
Oh.
Jennifer Chen. She
That's
was.
not Sin.
Oh, Jen Chen?
She used to be Sin.
Is it spelled the same?
That's her. What do you call?
Maiden.
No, she got
Maiden.
married and
Now her
No,
marriage
I mean
is
Sin
Chen.
like sign. Is it spelled like S?
So what are my limits of integration? When is sine theta equal to 1/2? Pi over 6 and 5 pi over 6. Some of you can probably do that in your head, right?
Yeah.
So I can go pi over 6 to 5 pi over 6 if you want, because that's how the thing is formed right there. Or you can go, I just want to go pi over 6 to, where, you remember what that was? Pi over 2 and times it by 2. Yeah, because it's easier to plug in pi over 2. It's a quadrantal angle, that's why, right?
Nah.
It doesn't matter to me, Mr. Park, I screw up on either. And now, you know what, to save time, I will leave the computation to you, but you see when you multiply this out, you're gonna get a sine squared theta, yeah? Yeah, so since you have this square here, you better know how to integrate sine squared and cosine squared, you gotta be good at that.
Wait, so did you remove the inner loop?
I did, what do you mean?
I mean, like.
We're just, that's what we're trying to find, just find the area of the inner loop.
Oh, okay, I see.
And let's do one petal of a rose curve then. R equals 3 cosine 2 theta. How do I know this is a rose curve?
Cause.
To the stuff
Because there's
formula.
no plus or minus.
Because we learned this, remember? Why do I keep on saying that? And this is not PCH, we reviewed this in August, remember? I decided next year if I teach PC, I'm not gonna do that review.
Why not?
Guys, no.
Because what do you remember about it?
Exactly.
But it's easier to relearn it after.
Okay, maybe I will, I'll think about it. How many petals does this rose curve have?
4.
4.
4. Remember, if this number is even, you have twice as many. If it's odd, that's how many you
No,
have.
but you have 6, it's just traced over it on top of the other, right?
No, there's only 4.
No, I mean like if it's an odd number.
No.
Really? I thought, cause like if
No,
it's,
it might get traced over, but that doesn't mean it has that many more petals.
yeah, but it gets traced over.
And how do I figure out where the first petal is? You guys remember? Because can I put the first petal anywhere I want?
No.
No.
You have to-
How do I figure out where the first petal is going to be? Cosine reaches its maximum value of 1 at 0. So if it's a cosine 1, you set the argument equal to 0. But if it's a sine 1, you set the argument equal to pi over 2, because sine of pi over 2 is 1. But this is a cosine 1, so 2 theta equals 0, therefore theta is 0. Oh, so the cosine 1 always going to start over there at the positive x-axis there.
Yeah.
Yes, Miss Brad.
I will say yes with the reservation,
What?
because what if there's a negative sign in the front?
Then it says,
But I won't do that to you, would I?
yes, you would.
Okay, then no. Then there's a reservation. So the first one occurs over here, and remember, they're all equally spaced apart. That's how it is, man. So here's the graph.
Never mind, it's not for you.
So So like on tonight's homework, I believe, what you have to do is you're gonna have to draw these graphs and they're gonna ask you, what is the slope right there? Or what is the slope at the tip of the petals of the rose curve? That's the kind of stuff you gotta do. And then we got, now all of these petals are supposed to be congruent, but they don't look like it in my graph. So again, if I wanna find the area of one of the petals of the rose curve, I need to know how it's being formed. So here, it's easy. 1/2 r squared d theta. What is r in my problem? 3 cosine 2 theta. And I'm gonna add up all of these sectors from, okay, now we know 0 is here. And then, what's the value of theta? Boom, when it reaches there.
That's it.
And again, right there, how far from the origin am I right there? If you're on the origin, how far are you?
Zero.
0, so just plug in 0 for r.
Four.
If I plug in 0 for r, you get cosine 2 theta equals 0. Therefore, 2 theta equals pi over 2, 3 pi over 2, and so forth. But we're just looking for the first time. So theta equals pi over 4. So we know theta is 0 here, and it's pi over 4 there. See that, if you get all these sectors, that gives you half the area of one petal. So what do I need to do to find the area of one whole petal? Times it by 2. And I will leave this integral to you because again, look, cosine squared. So you gotta use the identity 1/2 plus 1/2 cosine 4 theta in that one.
Wait, cosine squared? There's a cosine 2 theta.
Cosine squared 2 theta.
Oh, yes.
Yeah, so this is cosine squared 2 theta, so the identity will be 1/2 plus 1/2 cosine 4 theta.
My bad. With the 3.
So you,
With the 3 in the
yeah. All the constant, well actually it's a 9.
Yeah.
Alright, so you can just see how much fun this is gonna be.
So much fun.
That's it?
Alright, we have 9 minutes to discuss last night's homework. But before we discuss last night's homework, somebody actually came in for help, you know.
What was it?
Let's guess.
The people that don't need to come in for help. The people that do need to come in, they don't show up. They're
Is
like,
it?
they're like the invisible people.
I'll come later.
How do you know I was referring to you? Fuck you. There was one problem with last night's homework that nobody asked. We didn't do this on the board, but yet, when this person came in for help, can I erase it now?
Sure.
So I really think we should do this. This is 11.2, and don't worry, this is, hey, believe it or not, that was the last lecture of the whole year.
The last lecture.
Wait.
We are done with calculus.
This?
Yeah.
Drop the book.
Wait, what?
Wait, is that what's all of them?
No, 11.3 was last time.
Yeah, but when we went over 11.2 on the board yesterday, nobody asked about problem 56.
I was there.
And you guys don't understand how important this problem is, so I'm gonna do that now. Because I'm gonna tell you right now, this problem is on the test, because I wrote the test this morning. This problem's on the test.
Same numbers and everything?
No, not the same concept.
Wait, today's homework is the last one.
Yeah.
Okay, it's not the last homework,
There's a
it's the
practice
last
test.
lecture. In other
No,
words,
it's the last
this is the
homework.
last topic that we need to
The
cover.
last time we need to look at it.
How much longer are we?
You see it?
Yes, this is the last time we're ever gonna do book homework.
Oh.
We do everything tomorrow.
Everything is, so here, find underclassmen and start selling your books early.
Wait.
So what are you doing?
I'm still waiting.
Yeah, I literally just took my book.
We're supposed to be this, Paula, you're always 1 minute behind. We're supposed to be discussing 11.3, but I am upset because nobody asked about 56
Oh,
yesterday.
God, okay, sorry.
We were going
Didn't even
to, but then you
finish
stopped
like
that.
You didn't! You don't even know because you never even tried 56.
Yeah, I just. Yeah.
dx dt is cosine of t squared. dy dt is equal to sine of t cubed.
It's the multiple choice.
At time equals 0, the initial position is 4, 7. Where is the particle at t equal 2? Question mark. And this is multiple choice.
Mr. Bart, you lied to me this morning.
I lied to you?
Yeah, you said it wasn't on the quiz, but it
Oh no.
No, that wasn't on the quiz.
wasn't it basically?
No, see, this problem you have to use a graphing calculator.
Oh, but like it's. Let's go back.
No!
So mean.
No.
It's basically the same.
Well, I thought you meant with the calculator.
Oh no. It was just I was like I saw it.
See now, everybody, why didn't you just say that? Everybody knows it was Davis who came in.
This is a lot. I didn't make that.
This is why, okay, so they give you the x component and the y component of the velocity, right?
Yeah.
Oh, okay.
If you are given basically the x and y component of the velocity, and they give you the initial position, how do you find the position when t is 2? Yeah.
But you need to find.
Okay, so one way to do, now this is the way we did it on the board yesterday. If you know the velocity, how do you find the position equation? You take the antiderivative of that, but there's a problem here. What is the antiderivative of cosine t squared? Nomura? Does anybody know?
No.
No one knows. You cannot do that. We can't find the antiderivative. So, if we cannot find the antiderivative, we learned this a month ago.
Displacement.
Yeah. Okay, does this sound familiar? If you are given a function, and you have to find out something about its antiderivative, but you can't find the antiderivative, then what do we need to do?
Calculus.
Part
Wait, what?
2, except we gave it a name.
Code red.
Code red.
Oh, wait.
I forget this.
Yeah.
So that's why, and that's why I assigned the problem, because I'm telling you on the AP exam, this is super important, this problem. So what you do is you integrate the velocity, this is the velocity, from the x component of the velocity from, now what limit should I put on here? 0 to 2, because then one of them I know and the other one we're trying to find. So we integrate from 0 to 2. Now you gotta remember that this is the velocity now. So how does the fundamental theorem of calculus part 2 work? How do you compute an integral? You find the antiderivative of this. Yeah, but I don't know what it is, Mr. Park. Well, we kind of do. What's the antiderivative of velocity?
Position.
Position. So it's the position, plug in the top number, plug in the bottom number, and subtract. This is just simply called the fundamental theorem of calculus part 2. However, that takes too long to say. That's why we just call it code red. You guys, does that sound familiar?
Right on the
Which
AP.
problem was that?
How does this work, Mr. Park? Well, do we know what the x coordinate of the position is at 0? No. No. This is the x, this is the y. 4. This is 4. You can compute any integral on your calculator, right?
Yeah.
So you compute the integral in your calculator, and this is 4 here, so how do you find x of 2? Yeah, you just take this and add 4. So x of 2, the position of x when t is 2 is simply this integral plus 4.
Oh, that's cool.
Okay, so using the same technique, how do I find the y coordinate of the position here?
Place sign.
You do the same thing, integrate
What
the
side?
y component of the velocity from 0 to 2. What's the antiderivative of velocity? Position, plug in the top number, plug in the bottom number, subtract. This can be computed on your calculator. This we know is 7. So how do you figure out what y of 2 is?
That's 7.
Whatever you get here, plus 7.
It's pretty cool.
Okay, I'm telling you, this problem is on the test. I also put it on the practice test. So,
We have a practice test?
yes. You know how long it took me to make this practice test?
Is it the same kind of practice
You come
test?
in at 6 o'clock.
Where it's the same thing as a
It
test?
took me all yesterday to write problems, and it took me all morning today to find the answers. Because you guys want answers, right?
Wait, Mr. Park?
Yeah.
Wait, so is
He
this
said
this
no,
kind of
he said it wasn't
type of thing where
You
the
know
test
what
is
he says,
basically
nobody
the
needs
same thing as a
yes.
hypothesis test except you change numbers?
I did it wrong.
It'll be similar.
Oh, I don't like it.
Mr. Park,
Yes.
you have to
I
have
made
this.
a mistake.
Yes, I know we only have 2 minutes left. Don't worry, I'll write you a note for your next class.
Oh, well.
Except
Yeah.
for every two.
No, I'm not done.
Yeah.
Do we have any questions? We have time for one question. Go.
Okay, cities happen.
Dude, the homework was easy.
Really easy.
It was way
Number
too
10.
easy.
That's because there's not much count. This is just this is review.
Yeah,
Number 10, I didn't get that one.
Yeah, but I don't
Number
know
what?
right?
No, it says 29.
29.
This is 25.
Where's 29?
This number is
R
just
equal 8
like
sin
16, so why do you make
theta.
us
Sin.
like decimal?
Yeah, because
Please
in
stop.
honor of
It's
Jennifer
so
Sin.
There's no Jennifer Sin.
Now there's 2 ways to do this. We got a minute.
Full calculation.
Oh no, there's more.
What do you mean
That's
did?
kinda scary.
Okay, two ways to do it. You can draw the graph. What is this graph supposed to be? A circle, plot 0, go, plot 0. 0, plot pi over 2. 1, 2, 3, 4, 5, 6, 7, 8. There's the diameter. This is the circle right there. So you can clearly see the center is at 0, 4. So x minus 0 squared plus y minus 4 squared is equal to 16, right? That's one way to do it. Draw the graph first and then write the equation. Or the way that we learned last year, how do you change this to a rectangular equation? I'll just tell you, multiply both sides by r. Why do I multiply both sides by r? Because A, you somebody,
X squared plus y squared.
and A, you somebody,
Y.
y, and then now we got, we complete the square. What do I have to add to make a perfect square?
16.
16, add 16 to both sides, so you get x squared minus 4 squared equals 16. Same thing.
That we have to do both of them.
No, you don't have to do both ways, just do one way.
One way.
Probably the easiest is this way, yeah? I would hope by now we're BC people. We look at that equation, we know exactly what the graph is, we can just see it in our head. Okay, tomorrow we will address all the rest of the questions in whatever sections you want to go.
Alright.
Wait, so tonight's homework is the practice test, then, right?
No.
No. It's the second half of 8, 10, 11.3. 11.3. Yeah.
Oh, dude, I think I got less than a 50 on the clear.